Hello everyone. In this video, let's go over vectors, which is very important for both Physics 1 and Physics 2. So in physics, there are two different kinds of quantity. One is scalar quantity. Scalar. We can describe it as a single number, just a number. And then we have vector quantities. And the vector quantity is different from scalar quantities. Is that it has a magnitude and it also has a direction. So in the textbook, use a boat type, and then also we draw arrow on top of the letter to represent a vector. And then because vector has a magnitude, so if we want to write what's the magnitude of a vector, we don't write it in bold and we don't write the arrowhead, or you can also write it as the absolute value of the vector. So one example is that you move from one place to another place on the map. So you move a distance. So this is the magnitude of this displacement vector. And this displacement, if you want to let people know where you are, you also should have people know what direction you move. So this is the direction you move. And we can use arrows to represent a vector. In such a case, the length of the arrow, the length would represent the magnitude of the vector, and then of course the direction of the arrow shows the direction of the vector. If you have two vectors, they have two different starting points, they have two different end points. However, the direction from starting point to end point, direction from starting point to end point are the same, magnitude are the same. In such a case, we consider these two vectors equal each other. And if you flip the direction, if you flip the starting point and end point, you get the negative of the original vector. And we can try to add two vectors graphically. So if you have vector A, you have vector B, you want to add A and B together, give you C. What we can do, first you draw vector A, then you put the tail of vector B on the head of vector A. You connect the tail of vector A to the head of vector B, which gives you vector C, which is the sum of A and B. And the order doesn't matter. So you can add B to A, or you can add A to B. In such a case, you put the tail of A onto head of B. You connect tail of B to head of A, which also gives you the vector B plus A, and you can check B plus A exactly equals A plus B. So the order is interchangeable. You can apply this to more than two vectors. Even if you have more than two vectors, you add A, B, C together. First you put A here, you put tail of B on head of A, then you put tail of C on head of B, you connect tail of A to head of C, you find out what is vector A plus B plus C. And you can check if you do it in different order. For example, you add A and you add B and C together, then you add A, it will give you the same vector, in the sense that the magnitude is the same, the direction is the same. And then how do we do vector subtraction? What we do, we still do vector addition actually, because we know how to find out what's the negative of vector. So subtract vector B would equivalent to add negative B. And if you flip the sign, just flip the sign of B, you get a negative B. Subtract B equals add negative b, and this is how we do vector subtraction. So we draw a here and then subtract the b, right? So this is our b. So what we need to do, we need to flip the direction of b. This is our b. This is our b. You need to flip the direction of b, give us negative b. You put a tail of negative b to head of a. You connect tail of a to head of negative b. You find the vector a subtract b. You can also multiply the vector by a constant, or basically by a scalar. So if you multiply a vector by 2, its direction is not going to change. Its magnitude is going to double. Now if you multiply the vector by negative 3, its direction flipped, right? Because it's negative and the magnitude increased by 3 times. So there is a special addition of vectors, which is two vectors make right angle. So go to the example we did. You start from here. First you move in the north for 1 kilometer. Then you move to the east for 2 kilometers. So this is entirely in y direction. This is entirely in x direction. And this is your total movement. You have a movement of 2 kilometers in x direction and 1 kilometer in y direction. So you can calculate what will be the magnitude of your movement. So if we can recall what we learned in trigonometry, this is hypotenuse with 2 legs, 1 kilometer and another leg 2 kilometers. So hypotenuse should be square root 1 plus 2 square kilometer, or 2.24 kilometer. And then you can find out what's this angle. What's this angle? We should know 25 equals 2 over 1. 2. So you put it into your calculator. 5 is 10 inverse 2, which should give you 63.4 degrees. Now based on that, we find it's very convenient for us to find out the components of vector. So in 2 dimensions, you have vector, you have your coordinate system, your x, positive x, and your positive y. You can decompose A to a vector in x direction and y direction. This is the angle of the vector theta. This is hypotenuse, and this is the adjacent side of angle theta. So of course, you see AX in magnitude would be A cosine theta. And similarly, AY is A sine theta. And if you interpret AX as a vector in x direction, then your A is your AX plus AY. You can also see this graphically. This is AX in x direction, this is AY in y direction. You add those two vectors up, you get your A. And you can see, so let me also write it here. You can see because this is hypotenuse, A, magnitude A is hypotenuse, AX is one leg, AY is another leg for right angle triangle. So we can have A, magnitude of A should equals to magnitude of AX plus magnitude of ay squared, magnitude of ax squared plus ay squared. This is a relation between the magnitude of a vector and its components. And the components of vector can be positive or negative, depends on what's the angle of the vector. So we want to adopt such a way the angle of the vector would be always count from positive x direction. We call this one 0 degree, 90 degree. So you count counterclockwise from 0 to the vector itself. And in such a way, so those two equations would always be true. Ax would be a times cosine theta, and theta is the angle of the vector. You count starting from 0 degree counterclockwise to the vector. Ay is a sine theta. Now for this vector b is in the second quadrant. So cosine this angle will give us a negative x component, and sine will give us a positive y component. Now for c is in the third quadrant. So if you use this equation, your angle is actually between 180 and 270 degree. So your x component for C is negative, your y component for C is negative as well. So this is the recommended way how we're dealing with vector and its angle. You always start from 0 degree, go counterclockwise until you get to the vector, and we use this angle as the angle of the vector. Let's do one example. We have a vector with y component 9.6 meter. A makes an angle 32 degree counterclockwise from positive y-axis. What's the x component of the vector? What's the magnitude of the vector? So if we can draw what a vector looks like, it says vector A make a 32 degree counterclockwise from positive y-axis. This is A, and this angle is 32 degree. So which gives us theta A. The angle of this vector actually is 90 degree plus 32 degree equals 122 degree. Okay, good. And then we know AY is a sine theta. And theta, we just found out theta is 122 degree, right? Theta is 122 degree. So we can calculate what's the magnitude of vector A. A is AY divided by sine theta A, and AY is 9.6 meter sine 122 degree. If you plug in the numbers, it should be 11.3 meter. Okay, we found out the magnitude of vector A. Now it becomes easy. How do we find the x component of vector? And we know the angle of this vector is 122 degree. With negative 6 meter. See, you use these two equations, and you just use the angle of the vector coming from 0 to where the vector is. you always get the correct sum for the components. So this is why this is a recommended procedure. Now, after we find out the components, we can use components to find out how you add up vectors. If you have, look at the graph, if you have vector A plus vector B, from the graph you put a tail of B on head of A, and then join the tail of A to head of B, you find what is A plus B. R is A plus B. And the x component of R is x component of A plus x component of B. Y component of R equals y component of A plus y component of B. And sometimes we can also use unit vector to represent the vector. So x is a unit vector in x direction. It has magnitude 1, pointing in the positive x direction, j in the y direction, in the positive y direction with magnitude 1, k is magnitude 1 in the positive z direction. So you can write a vector as the magnitude is x component times I plus magnitude of y component times j plus magnitude of z direction times k. So in 2 dimension, of course, we only have x component. So this is I, this is ax, this is magnitude of x times I, magnitude of ay times j. If you add those 2 vectors together, this one and this one, it'll give you A. So let's use some more example to help us understand. We have vector A, its magnitude is 2.8 centimeter, and its direction is 6 degrees above x-axis. This is vector A in the first quadrant. Vector B, magnitude 1.9, is 6 degrees below positive x in the fourth quadrant. Okay, my question, what's the angle of B? So angle of A is easy, starting from 0, 6 degrees. But if use my convention that I said I always recommend you use this, you start from 0, you go all the way to B. This is angle of B. And in such a way, theta B should be, I would think is 36 degrees subtract 6 degrees, right? The entire thing is 3360. This is 60, so theta B is 300 degrees. Okay, good. Now we're ready to find out the components of vector A and vector B. Let's see. Theta A is 60 degrees, so AX is magnitude of A, cosine 60 degrees. The magnitude of A is 2.8. Plug 2.8 there. We find AX is 1.4 centimeter. AY is A sine 6 degrees, 2.425 centimeter. Now theta B is 300. So BX is magnitude of B cosine 300 degree, which actually is a positive number if you put that into your calculator, and of course remember to put your calculator into degree mode. EY is B sine 300 degree, negative 1.645. centimeter. So we find the components of A, AX, AY. We find the components of B, BX, BY. Now we need to use component to calculate A plus B, A minus B, and B minus A, using component to find the magnitude and direction. Of course, we still first need to find out the components of A plus B. So let's call, this is part A. Let's call R equals A plus B. So Rx equals AX plus BX, using what we found out in the previous slides. X 1.4, BS 0.95. You add those two together. Do the same for Ry, which is AY plus BY. Go back to the previous slides. Find out what is AY. What is BY? Now this time BY is negative. We find the components of Rx, Ry, components of A plus B. So now we are ready to find out what's the magnitude. Using Pythagorean theorem, we find it is 2.48 centimeter, and the angle of this is A plus B. We need to find this angle, so you need to find y over Rx, which is 0.78 over 2.35. We find that this angle is 18.5 degrees, which looks almost right, about right at 0.078 to 0.35. Yeah, looks right on the plot. Now we do the same to find out what is A plus B. We call R A subtract B. We call R A subtract B. You find X component of R. AX subtract BX. Go to the component slice. Find out what are the components. Find out what are the Y components. Ry is AY subtracted BY. Now the thing is BY is negative, so subtract the BY become positive. We're able to find out what's the magnitude. And we're able to find out what's the angle. Tangent theta is Ry over Rx. They're both positive, so make it put it into your calculator. You find this angle for R. Okay, you can repeat what we did for part B. If you do B subtract A, so yeah, you can call R equals B subtract A So Rx is Bx subtract Ax, Ry is By subtract Ay, being other numbers. But we also know, so I leave this to you, okay? You plug in all the numbers, find out Ry, find out what is R for B subtract A. But if we do an observation, we have R equals B subtract A equals negative of A subtract B. So it has the same magnitude. For this one, RR should have the same magnitude as what we did in part B, which is 4.09. And the angle on the other hand would be 180 degree. 180 degree different from the previous angle. So for this one, theta R is 180 degree from this is theta A subtract B, 180 degree different from theta A subtract B. So for this one, we should have R equals 83.7 plus 180 degree to 63.7 degree. Okay, let's have one more example with components. So in this one, we are expressing A as x component 4, y component 7. So in terms of unit vector I, A 4, x component 7, y component in terms of j, B x component of 5 in terms of I, y component negative 2 in terms of j. We want to find out the magnitude of each vector. So A, start with vector A, magnitude A equals ax squared plus ay squared, 4, 7 squared. This magnitude of A is 8.06. Magnitude of B, bx squared plus by squared, and the bx is 5, by is negative 2. So put it into your calculator, this is 5.39. So this is magnitude of A and B. And for part B, express vector A subtract B. So let's see, A subtract B is ax subtract bx I plus ay subtract by j. Now ax is 4, bx is 5, ay is 7, by is negative 2, negative 1, then j. So this is a component expression of A subtract B.